Recording in progress.
Hey guys, we are going to take a look at some of your review problems today. So we're on page 34 in your packet, and we're going to look at some of your review problems. And page 34 is all about factoring and finding our intercepts. So to start, it says we want to change the function to factored form and state the x and y intercepts. So since we have standard form here, I can identify the y-intercept pretty easily. My y-intercept, remember, is that constant term in standard form. So in this case, my y-intercept is 45. From here, I want to change my function to factored form so that I can find my x-intercepts. The first thing we want to do anytime that we're going to factor something is start by looking for a greatest common factor for all of the terms. And if I take a look at my problem here, all of my coefficients are divisible by 3. So I'm going to pull out a GCF of 3 to start. That would leave me with x cubed plus 3x squared plus 5x plus 15. Now I have a polynomial with 4 terms, so we're going to factor this by grouping. So first 2 terms make a group, last 2 terms make a group, and I'm going to find the GCF, that greatest common factor of each group. So for my first group, the GCF is x squared. Left over, I have x plus 3. For the second group, my GCF is 5. When I factor this out, left over, I would have x plus 5, or 15 divided by 5 would be 3. Remember, we want our piece in parentheses to match because this is our new GCF, our new greatest common factor, since it's common to both terms. And then left over, we have x squared plus 5. So our factored form right now, don't forget to bring down your original GCF, looks like this. Remember, anytime we still have a power of x, we want to double check to see if I can continue to factor this. I've got 2 terms in an even degree. That makes me think maybe difference of squares, but I don't have a difference here. This is addition. So this is as factored as this is going to get. So my factored form for my function is here. And then my x-intercept that I can identify from here would be -3. Can't get an x-intercept from here yet. We've only looked at x-intercepts when we have just x to the first power, so my x-intercept would be -3. For number 15, again, I'm going to start by looking for a GCF. I don't have one. So since I have 4 terms, I'm going to use grouping. The GCF for my first group is x squared. Left over, I have x plus 8. The GCF for my second group would be -4. Since my first term in this group starts with a negative, I'm going to factor out the negative. Remember that that changes my signs for what's left over. So I would have positive x plus 8. And my stuff in parentheses is the same, so I can pull that out. So I get a factor of x plus 8, and then left over, I have x squared minus 4. Since I still have a power of x, I want to look to see if I can factor this some more. I've got 2 terms, even degree, and subtractions. That makes me think I can factor this more with difference of squares. So if I check that here, I could square x to get x squared, and I could square 2 to get 4. So I can continue to factor this. So this would be x plus 2 times x minus 2. And then don't forget our factor of x plus 8. So there would be my factored form of this function. And now let's talk about those intercepts. So our y-intercept is our constant term from standard form. So that would be -32. And then our x-intercepts come from factored form. Since these are all x to the first power, I'm going to get x-intercepts from each of them. And so I would have -8, -2, and +2. Let's move on to number 16. 4 terms again, no GCF for all the terms, so I'm going to go straight to grouping. The greatest common factor for my first group would be x squared. That leaves me with x minus 9. For my second group, the GCF would be a +2. That leaves me again with x minus 9. My stuff in parentheses is the same, so that's my new common factor. And I'm left with x squared plus 2. Again, anytime I have a power of x, I want to double check to see if I could factor this some more. So So I've got two terms, even degree, but we don't have subtraction here. So this is going to stay as it is. There's the factored form of my function. The only x-intercept I'm going to get from this would be 9. And then my y-intercept from standard form would be negative 18. Number 17, same idea. This time I do have a common factor for all my terms. All of my coefficients here are divisible by 5. So I'm going to start by factoring out of 5. That leaves me with x cubed minus 6x squared plus 3x minus 18. Again, I've divided 5 out of all of these coefficients, and this is what's left. Now that I've got 4 terms, and I've pulled out my GCF, I'm going to use grouping to continue to factor. The GCF for my first group is x squared. That leaves me with x minus 6. The GCF for my second group would be 3, positive 3. That would leave me again with x minus 6. My stuff in parentheses is the same, so that's the new GCF that comes out. I'm left with x squared plus 3. Again, I want to look to see, can I keep factoring this? 2 terms, even degree, but it's addition, not subtraction. So I can't use difference of squares here. That's as factored as this guy gets. Don't forget to pull your original GCF down as you give the factored form of your function. Our y-intercept for this problem would be negative 90. Again, that's the constant term from factored form. And the x-intercept we can see from factored form would be positive 6. For number 18, we only have 3 terms. We're going to use a little bit different strategy here. We're still going to start by looking to see if we have a greatest common factor for all the terms. We don't for this particular problem, so I'm going to look at a 3-term factoring method. Since we have a lead coefficient that's not 1, I'm going to use AC method here. So I'm going to take my A value of 2 and multiply by my C value of negative 9. That gives me negative 18. And now I want factors of negative 18 that add to 3. You may need to make a list here, 1 times what, 2 times what, 3 times what, until you find the factors that you need. We're going to want 3 times 6. And again, to get a negative, that means one of my factors needs to be negative. If the 3 is negative, then when I add these, I would get positive 3. So these are the factors I want. Now my next step for AC method is to rewrite this. But remember, I'm only changing the middle term. So my first term stays the same. And then my middle term, I'm going to split up into 2 using those factors that I've chosen. So minus 3x plus 6x. And then my last term stays the same. And again, notice that if I were to combine these, minus 3x plus 6x, we get back to my original middle term. The reason that we do this is so that now I have a polynomial with 4 terms, and we can use our old buddy grouping to be able to factor here. The GCF for my first group is x. That leaves me with 2x minus 3. The GCF for my next group is 3. That would leave me with 2x minus 3. My stuff in parentheses is the same. So that comes out. And then I'm left with x plus 3. So there's my factored form here for number 18. My y-intercept is still that constant term from standard form, negative 9. And then my x-intercepts here, here's the easy one. My first x-intercept I'm going to write down is negative 3. And then this is a little trickier because x has a coefficient. Remember, you can set that equal to 0 and solve. So I'll do that really quickly here. We would get 2x equals 3, and then divide both sides by 2. So we would get 3 over 2. Or if you remember that sort of shortcut we had talked about in class, it's opposite sign here, but then divide by that coefficient. And that's what we see here for our other x-intercept. For number 19, again, we're going to want to use AC method here since I have a lead coefficient that's not 1. No GCF to pull out at the start, so I'm going to go ahead and multiply my A and C terms. That gives me 12. 3 times 4 is 12. And now I want factors of 12 that add to negative 8. 12 is positive, so I could have gotten that by taking a positive number multiplied by a positive number, or a negative multiplied by a negative. In order to get negative 8, that means I'm going to want 2 negative factors here. Factors I want would be negative 2 and negative 6. Those would multiply to positive 12, but add to negative 8. And then again, I'm going to keep that first term the same. but replace the middle using the factors that I've chosen. N term stays the same again. Now we're going to group since we have 4 terms. The GCF for my first group is x. That leaves me with 3x minus 2. The GCF for my next term, these are both even, so I could take out a 2. And since my group starts with a negative, I'm going to take out -2. Remember to be careful with your signs here. So 6x, take out -2 or divide out -2, factor out -2, would leave me with 3x, and -4, factor out -2 to leave us with -2. My stuff in parentheses is the same, so that comes out as my new GCF, and I'm left with x minus 2. Everything's down to x to the first. I've got no more exponents, so this is as factored as this can get. Our y-intercept, again, comes from standard form. That would be a +4. And our x-intercepts would be, change the sign, divide by the coefficient, so 2/3 and 2. For number 20, again, no GCF here. This copied a little weird. That should be a plus sign. So I'm going to use AC method here since I have a lead coefficient that's not 1. If you prefer to use guess and check on these problems, that's fine too. I like to use AC because it gives me a little more structure. So 2 times 5 is 10. Factors of 10 add to 11. Well, that'd be 1 times 10. So I'm going to rewrite this as 2x squared plus 1x plus 10x plus 5. And then I'm going to use grouping. The GCF for my first group would be x. That leaves me with 2x plus 1. The GCF for my second group would be 5. That leaves me with 2x plus 1. Stuff in parentheses is the same, so I can pull that out as my GCF. And left over, x plus 5. Just as a reminder, if I distribute back, I should always get the original problem. So here's a mistake I see pretty frequently. If our GCF is actually one of the terms, a lot of us have a tendency to not write the 1. But if I were to multiply that back, I would only get the 10x. When I have the plus 1 there, then I get plus 5. So I should get, when I distribute back, the original thing that I had. And for my factored form, if I were to multiply this back together, if I were to distribute, I would get, when I combine like terms, my original problem. Okay, x-intercepts here would be -1/2 and -5. My y-intercept here would be +5. Number 21 is another trinomial, another 3-term problem. I do not have a GCF for the entire problem. So again, I'm going to use AC method since my lead coefficient is not 1. So this would be 4 times 4, which is 16. And I want factors of 16 that add to -17. So I'm going to use -1 and -16. So I'm going to rewrite this. That first term stays the same. Be careful with your exponents on this problem. Instead of x squared and x, we've got x to the 4th and x squared. So -1x squared minus 16x squared plus 4. Remember, we have to match the exponents to the original problem. Now I'm going to use grouping. The GCF for my first group is x squared. That would leave me with 4x squared, right? X to the 4th, take out x squared, I'm left with x squared, minus 1. And then for my second group, I have a GCF of 4 here. Since the first term in my group is negative, I'm going to take out a -4. That would leave me with positive 4x squared minus 1. Remember, I took out a negative, so be careful with those signs. Now my step in parentheses is the same, so I'm going to go ahead and pull that out, 4x squared minus 1, and I'm left with x squared minus 4. Now remember, we said anytime I still have an exponent on my x, I want to check to see if I can continue to factor. 2 terms, even degree, subtraction. 2 terms, even degree, subtraction. I'm going to try difference of squares on both of these. So to get 4, I squared 2. To get x squared, I can square x. And to get 1, I can square 1. So this first guy, I can factor farther into 2x plus 1 times 2x minus 1. And for my second term here, To get x squared, I would square x. To get 4, I would square 2. So this would be x plus 2 times x minus 2. There is my final factored form. Now let's talk intercepts. So my y-intercept, again, comes from standard form. That would be positive 4 here. My x-intercepts, I'll have several of them this time. Change the sign, so -1, divide by 2. And then change the sign, +1, divide by 2. And then -2 and +2. A lot of x-intercepts on that one. For number 22, this time our lead coefficient is just 1. We have no GCF for this problem, and since our lead coefficient is just 1, I'm going to stick with guess and check for this one. You can use AC method if you want, but guess and check is going to be a little faster. So I'm going to look for factors of 64 that add to 16. I want 8 and 8. Again, if you need to, make a list, 1 times something, 2 times something, 3 times something, until you find the factors that you need. We want 8 and 8 here. So this would be x plus 8 times x plus 8. Remember, these I can only throw directly into factors if my lead coefficient is 1. For any other problem, like the chunks that we just did, the sort of last 4 that we just did, I had a lead coefficient that was not 1, so I used that full AC method. But for number 22, our lead coefficient is 1, so that is our factored form. Our y-intercept for this problem is 64, and our x-intercepts would be -8 and -8. So I'll go ahead and write it twice, even though it's the same number. For number 23, I have a GCF here. All my coefficients are divisible by 5, and all my terms contain an x. So I'm going to pull out a 5x. That would leave me with x squared plus 2x plus 4. And now I want to look to see if I can continue factoring this piece in parentheses. So since I have a lead coefficient of 1 here, I could just use guess and check, and I would need factors of 4 that add to 2. Well, my factors of 4 would be 1 and 4, or 2 and 2, or the negative options. None of these add to +2. So I can't factor this anymore. If you run into a problem like this, I always want you to check to see if you can factor some more. In this case, we can't, so we're done here. This is our factored form. Our x-intercepts that we can get then would just come from here. That would be an x-intercept of 0. And then our y-intercept would be, well, I don't see a constant term here. So that means that it's also 0. My y-intercept is not 20, okay? The 20 is not a constant term because it has a variable. Remember, the y-intercept comes from the constant term. Since I don't see it here, that means that it's 0. A few more on this page. Number 24, no GCF for the entire thing, and my lead coefficient is 1. So we're going to go ahead and use our guess and check method here. I need factors of -18. That would add to 3. So I'm going to use 6 and -3. So this would be x plus 6 times x minus 3 for my factored form. My y-intercept is -18, and my x-intercepts are -6 and +3. For number 25, I have a GCF here of 4, so I'm going to go ahead and factor out my GCF. That would leave me with x to the 4th plus 1x squared minus 2. Again, be careful with your exponents. And now the stuff I have in parentheses still has powers of x, so I'm going to look to see if I can factor this some more. My lead coefficient is 1, so I'm going to try AC method. So I want factors of -2 that would add to 1. That would be -1 times 2. So this would be x squared minus 1 times x squared plus 2. Since I still have powers of x here, I'll check to see if I can continue factoring. I've got 2 terms, even degree and subtraction, so we'll try difference of squares on this one. X squared would get me x squared, and 1 squared would get me 1. Over here, I've got 2 terms, even degree, not subtraction. So this one is going to stay as it is. My factors from here would be x plus 1 and x minus 1. Don't forget to bring down your GCF from the beginning. And don't forget to include our second x squared factor. So there's my factored form for number 25. My y-intercept, again, comes from standard form, that constant term at the end, in this case, -8. And then our x-intercepts would be -1 and +1. Number 26, I've got just two terms here. So two terms, even degree, subtraction. That makes me think difference of squares. So I'm going to see what did I square to get each of these terms. To get 4, I squared 2. To get x squared, I squared x. To get 49, I squared 7. So my factored form here would be 2x plus 7 times 2x minus 7. That's my factored form. My y-intercept would be -49. And then my x-intercepts would be, change the sign, -7 to 5. So -7/2. And then +7/2. Number 27, I have a GCF I can take out at the start. So I'm going to divide out a 2 or factor out a 2. That leaves me with x squared minus 9. Now I've got two terms, even degree, subtraction. We're going to use difference of squares again. So I would square x to get my first term. I would square 3 to get my second term. So this would be x plus 3 times x minus 3. And then don't forget your GCF from the beginning. There's my factored form. Our y-intercept, again, comes from standard form. That's -18. And our x-intercepts would be -3 and +3. And we'll go ahead and do our last couple of factoring problems on the top of page 35. Number 28, again, I have a GCF I can pull out here. Both 20 and 45 are divisible by 5. So I'm going to start by pulling out my GCF of 5. That would leave me with 4x squared minus 9. Two terms, even degree, subtraction. So I'm going to try difference of squares to keep factoring here. To get 4, I would square 2. To get x squared, I would square x. To get 9, I would square 3. So my factored form here would be 5 times 2x plus 3 times 2x minus 3. My x-intercepts would be -3/2 and +3/2. My y-intercept is -45. And then finally, for number 29, our last factoring problem, again, I'm going to look for a GCF to start. Now, -9x squared and +16 don't appear to have a GCF. However, my lead coefficient is negative, so I'm going to go ahead and factor out -1. That would leave me with +9x squared minus 16. When I factor out that lead coefficient of -1, now I've got two terms, even degree, and subtraction. This is a difference of squares. So to get my first term, to get 9, I had to square 3. To get x squared, I squared x. To get 16, I squared 4. So my factored form for this function would be -1 times 3x plus 4 times 3x minus 4. My x-intercepts then would be -4/3 and +4/3. My y-intercept would be +16. So there's the factoring portion of our review. Remember, always look for a GCF to start, and then I choose a method to factor based on how many terms I have in my problem.